So this will be my second video for my physics assignment, and this is the second chapter, and it's called Wave Motion and Sound. So number one, mechanical waves. So energy travels in two forms, which are particles and waves. So wave is a disturbance of a medium. It transports energy, but it does not it transports energy but without permanently transporting its matter. While in wave, the particles of a medium is temporarily displaced at first, and then it returns to its original position. So there are two mechanical waves which are most commonly known, and they are the transverse and the longitudinal waves. So let's talk about the transverse wave first. The transverse wave particles of the medium are displaced in a direction perpendicular to the direction of energy transport. So the particles do not move along the wave. They oscillate up and down, as you can see in the diagram that I have put it in here, about their individual equal position as it passes. So for longitudinal, the longitudinal wave, the particles are displaced in direction parallel compared to in the energy transport compared to transverse, which is perpendicular. So the particles do not move up and down, but it oscillates back and forth about their individual and equal positions. So another type of wave is the water wave. So water wave is a wave that combines both transverse and longitudinal wave. So as the wave travels through the water, the particles travels in clockwise circles. The radius of circles decreases and the depth of water increases, while the depth of water increases. So these are the characteristics of a wave. It has an amplitude, it has a wavelength, it has frequency and period, and it has the wave velocity. As you can see, the amplitude is the height of how high the frequency is, while the wavelength, as you can you already know that in light. So the relationship between wavelength, frequency, and velocity. It's a simple thing. You use a formula, which is velocity. It equals to wavelength times frequency. It's just simple. You have a frequency value and a wavelength value. You just multiply it and you have the velocity. Alright, interference of waves and standing waves. So interference wave, or simply known as also superposition wave, occurs at points when two or more waves meet each other. At these points, the combination of waves produce either larger or smaller waves, or even cancel each other out, making no disturbance at all. So there are also two more types of interference wave. There's the constructive interference wave, then there's the destructive interference wave. The constructive interference, it is two waves having different amplitude in a phase. The superposition of the two waves produces an increase in disturbance and a waveform with great amplitude. For the destructive interference, it is two waves having amplitude with the second wave out of phase. See the difference? The constructive is in phase, while the destructive is out of phase. So when it is combined, its effect is reduced. It reduced the amplitude of the first wave. So that's the difference between constructive and the destructive interference wave. This is an example of it in the diagram here. Okay, sorry. So number 6, standing waves. Standing waves occurs in wires that are tightly stretched between 2 points. So if these wires are plucked or caused to vibrate, transverse wave travels to the end and is reflected back. So it just goes back and forth. So as the waves cross each other, they travel backwards and forwards along the wire. Now, the waves that are in phase, it combines together, and the amplitude becomes larger. Standing wave patterns are characterized by certain fixed points along the medium which undergo no displacement. They are called the knots. Meanwhile, a midway between every consecutive nodal point are points which undergo maximum displacement. They are called the antinode. Okay, sound. So sound is an energy and is produced when an object vibrates, causing the surrounding air particles to vibrate. Sound also travels through air or other mediums in the form of a longitudinal wave. So sound is an example of a longitudinal wave. Sound waves are also acoustic waves. They are regions of high pressure and low pressure. So these are known as rarefaction and compression. So now we have a sonic range. The sonic range can be detected by the human ear, which has the frequency of between 20 and 20,000 hertz. The speed of sound depends on the medium through which it travels. Sound cannot travel through a vacuum, so sound cannot travel in space. Its speed is greater in solids than in liquid or gases because it is easier to transmit sounds with materials that having molecules that are closely packed to each other. The speed of sound increases with an increase of air temperature. So as air temperature increases, the speed of sound increases. Therefore, measuring the aircraft speed will vary at different altitude level. The sound speed at sea level is considered to be at least 340 meters per second or miles per second at 15 degrees Celsius. Now we have the Doppler effect. So the Doppler effect is the change in frequency which occurs when the source that is emitting the sound wave is moving. So let's see. Sound waves in front of object becomes clear together, giving an appearance of a smaller wavelength and a greater frequency. Waves behind the moving object, the opposite occurs, giving the appearance of longer wavelength and lower frequency. When there is a relative motion between a source of waves and an observer, the apparent frequency of the waves is different from their frequency at the source. When the source of sound moves, the frequency ahead of it will be higher than it is behind. So, as an example, a car passes over you. As it approaches, the sound becomes much more louder and high-pitched. But when it passes, the intensity drops and the frequency becomes lower, decreases. Other such examples are navigation equipment, and police radar guns. B. Sound intensity. So sound intensity is determined by amplitude of sound wave. A higher amplitude produces a higher sound wave. Sorry. So it is measured in decibels. And 1 decibel, the smallest change in sound intensity, can detect the human ear. Frequency. The numbers of Frequency is the numbers of vibration completed per second. The higher the sound, it produces a higher pitch. Sound vibration. It causes wave which radiates out from their source at the speed of sound. So, as an example, aircraft moves less than the speed of sound. So the sound moves ahead of aircraft. The aircraft flies at the speed of sound, it produces shock wave. Speaking about the speed of sound means the speed at which the mechanical vibrations of sound travel in elastic medium. It varies with temperature and altitude. Mach number. So Mach number is the ratio of the speed of airplane to the speed of sound in the same atmospheric condition. So to gain a Mach number, you just have to divide the value of the speed of object and by the speed of sound. Resonance. So resonance is the natural frequency of a given object naturally or without the external force. Two objects having the same frequency, if one vibrates, the other will vibrate as well. So that is all from me, and I hope it's okay. It's okay, and I'm sorry for any mistakes that I've done. And thank you for watching.